Hi, my name is Alejandro Reyes, and this is my demo of my senior design project that I did during this spring semester. And it's a hybrid synthesizer, which is gonna be mixing analog sound with a digital sound. And as you can see, these are the modules that are all designed by me. I'm gonna start showing from the power supplies, which I think is the most important. As you can see here from the transformer, these transformers are taking the voltage from the wall, and so I'm getting the ADC stepped down on 24 volts because those are 16.5 RMS. They're going to this AC to DC converter, who's gonna then power my power supplies. I have to use multiple power supplies because for the modules that I'm using in my analog synthesizer, I'm using different requirements, plus 15, minus 15 for the VCO and my op-amps. Then I have a plus 12 volts and minus 12 volts for the multiplier or the VCA. And then I have the plus 5, minus 5 for my control voltage control, for my control voltages for the envelope generator that I'm using here. And lastly, I have to do one board for the digital power. In this way, I was not mixing the analog and the digital power here. So you can see here as a minus 15, and minus 12, minus 5 volts, plus 15, plus 15, plus 12, plus 5 volts, analog side. This is just for my digital, which I'm stepping down from 23 to 5 volts to power my launchpad, which has a processor. I'm using a TMS 28 from the C2000 family from Texas Instruments, and a codec which I solder on top. And this is reading basically a MIDI message sent from this keyboard. Therefore, this keyboard sends a MIDI message to the processor. The processor is able to take polyphonic waves, polyphonic notes, which means more than one note at the same time. 1, 2, 3, 4, 5, 6, 7, 8, and that's just an example. Everything is done like on the real time. Then the sound goes to this board, which is gonna be mixing with an analog VCO, so I can have different kind of waves producing a sound. I have a sawtooth, a triangle wave, and a pulse wave. So now you're hearing the pulse wave, and I can actually change the PWM intensity. As you can hear, same note, and I can just change the PWM there. Then I can, for example, change to a triangle wave, and I'm mixing this sound. So now it's just the codec, but now instead it's gonna be only the VCO. So I can just do these. When you move this potentiometer, I can mix these sounds. As you can hear, the sounds are mixed from digital, and which is the sine. It's just a sine wave, a pure sine wave. Then I have a 3-band equalizer then before on the output stage, where I can change the bass. Give more bass, take away the bass. Give more mid, and with the high frequencies as well, I can do it. And then, as you can see on the screen of my computer, which I'm using my oscilloscope to check the kind of the waveforms, I can show how I can change the attack, and I can change, for example, the decay, or if I can increase the sustain as well and do it longer, as you can see. Then they can be mixed, as you can see. Now we are only listening to the analog oscillator right now, and then I can give some digital sound, some sine wave, as you can hear now. And this is it. This is my senior design project for this semester, the Electrical and Computer Engineer Program Department from the University of Florida.